Welcome. In this video, we're going to be discussing creating Bootstrap confidence intervals. So, the Bootstrap technique can be used to find confidence intervals. It can also be used to estimate standard error of statistics and various other things. What we're going to be focusing on in this video, though, is using it, or at least one technique for using it to find confidence intervals. The Bootstrap technique, it's most often used whenever the traditional or standard methods, sometimes referred to as frequentist methods, are unavailable. So maybe you're making a confidence interval from U or a confidence interval for P, and you don't meet the sample size conditions, or some other condition, some other assumption at the beginning is violated. So you're not able to use that confidence interval formula that you had hoped to use. Well, a technique you can use to get around that is Bootstrap distribution. So just to sort of review a few Bootstrap items, so a few terms. A Bootstrap sample, it's a random sample taken with replacement from the original sample that is of the same size as the original sample. So you can essentially think about if you've got a sample of 20 observations, well, to take a Bootstrap sample, randomly select one of those 20 observations, write it down, put that observation back, do it again, do it again, do it 20 times, and then that would be your Bootstrap sample. A Bootstrap statistic is simply a statistic computed on the Bootstrap sample. So it could be a mean or an average, so you could calculate that. It could also be a proportion or any other value that you'd like it to be. Then a Bootstrap distribution is the distribution of many Bootstrap statistics. So you'd create many Bootstrap samples, calculate a statistic on each of those samples, and then look at those. How many you use kind of depends. A lot of simulations. When I was doing my dissertation work, I was using 100,000 Bootstrap samples. That's how many simulations I was running. Generally speaking, the more the better. Obviously, you get to a point where there's sort of diminishing returns in the sense of, yeah, you can do more, but it just doesn't gain you that much. A couple of notes about the Bootstrap distribution. It is centered at our original sample statistic, and this should at least somewhat intuitively make sense. Because again, let's think about where our Bootstrap distribution comes from. Our Bootstrap distribution comes from Bootstrap statistics. Those statistics are calculated from Bootstrap samples, and Bootstrap samples come from the original sample. So then all this data that we're collecting on this Bootstrap distribution, it all is coming from the original sample, so our Bootstrap distribution will be centered at that original sample statistic. And then also, the standard deviation of the Bootstrap distribution is a good estimate of the standard error of our original sample statistic. So, how to actually use a Bootstrap distribution to create a Bootstrap confidence interval. If our Bootstrap distribution is approximately symmetric, we can construct a confidence interval by using the percentiles of the Bootstrap distribution in a way that the proportion of the Bootstrap statistics between those percentiles matches our desired level of confidence. So to look at this graphically, if we were wanting to create a P% confidence interval, then what we would want to do, if we're looking at our Bootstrap distribution, if that's what this graphic is, then we would want P% to be in the center there, and then we would have our upper and lower bounds, and those would correspond to percentiles, whatever would be appropriate. So for example, if we were making a 90% confidence interval, that means we want that middle portion to be 90%. Well, if that middle portion is going to be 90%, the area in both tails combined is going to be 10%, So in each tail individually, it's going to be 5%. So our lower bound is going to be the 5th percentile. Our upper bound is going to be the 95th percentile. We could do the same thing for a 95% confidence interval. We'd want the middle 95%. So the area in both of our tails combined would be 5%. So in one tail, or in each tail, it would be 2.5%. So our percentiles would be the 2.5 percentile and then the 97.5 percentile. Stuttered for a second there. Math is hard. Anyways, all right. So let's actually try to apply that to an example. So suppose we have a bootstrap distribution and various percentiles are given in this table. So in other words, the cutoff for the lower 0.05% is going to be 0.375. The cutoff for the bottom 5% is going to be 0.391, so on and so forth. So we can use these percentiles, we can use this table to create confidence intervals. So for example, if we wanted to go, okay, using the percentile method, what would be a 90% confidence interval based off of this bootstrap distribution? Well, if we're wanting to make a 90% confidence interval, then that means, again, we want the middle 90%. So in each tail, we're going to have 5%. So we're going to want the 5th percentile, which in this case is going to be the 0.391. And then we're going to go up to the 95th percentile. So between the 5th and the 95th percentile is going to be the middle 90%. So our 95th percentile, according to the table there, is going to be 0.431. And this would be a 90% confidence interval. Now, if we wanted to make, for example, a 99% confidence interval, well, we want the middle 99%. So if we want the middle 99%, that means in both of our tails combined, we're going to have 1%. That means in each tail individually, we're going to have a 0.5%. So what we're going to want is the 0.5 percentile and then the value that's going to give us a 0.5% above it, which would be the 99.5 percentile. So if we're looking at the chart here, our 0.5 percentile, so 0.5% corresponds to 0.378. And then the 99.5 percentile is going to correspond to 0.442. So our 99 percentile, or I'm sorry, our 99% confidence interval would be 0.378 up to 0.442. Now, the interpretation of bootstrap confidence intervals are going to be the exact same thing as the interpretation of other confidence intervals. So if we were dealing with, for example, just to review, a 99% confidence interval, what that means is if we took a whole bunch of samples and for each one of those samples we calculated a statistic. So you can envision, okay, we got a list of a whole bunch of statistics, and then we use each of those statistics to calculate a 99% confidence interval. So now we got a big old long list of 99% confidence intervals. Well, if we knew what our parameter was, that means about, and we could figure the percent out exactly if we knew the value of the parameter, but about 99% of that long list of 99% confidence intervals that we have, about 99% of those would contain the parameter. So, For example, if you had a list of 1,099% confidence intervals, well, then we would expect 990 of those to contain the parameter. Now, are we guaranteed to get 990 that contain the parameter? No, because we are dealing with a random quantity. So it could be we get 990, could we get 993, could be we get 982. Whatever. We're not guaranteed to get 990, but that's the value we expect to get. All right. Thank you. And with that, that'll conclude our video discussing creating confidence intervals using a Bootstrap distribution. Thank you.